You are moving faster than you feel, standing still at the equator. With your feet apparently fixed to the ground, your body is being carried eastward at about 465 meters every second. That is roughly 1,670 kilometers per hour. You do not feel it because the ground, the air, the oceans, the buildings, the trees, and your bones are all sharing the same motion. The trick is not that Earth is motionless. The trick is that everything around you is moving with it. So, if Earth stopped rotating for 1 second, the first thing to understand is that the planet would not be the only thing involved. The solid ground might stop, but your body would not politely stop with it. The atmosphere would not politely stop. The oceans would not politely stop. Every loose object, every cloud, every aircraft, every ship, every window, every wall, and every human body would still carry the eastward momentum it had a moment before. The simple version is that Earth stops and then starts again. The real version is much more violent. Earth is not just a ball in space. It is a rotating system with mass, momentum, fluids, crust, atmosphere, and oceans all coupled together imperfectly. When that rotation is suddenly interrupted, the system does not become calm. It tears against itself. At the equator, the surface speed from Earth's rotation is highest because the equator traces the largest circle in one day. The circumference of Earth near the equator is about 40,075 kilometers. Divide that by 1 sidereal day, about 23 hours and 56 minutes, and the surface speed is about 465 meters per second. At higher latitudes, that speed is lower because the circle you travel each day is smaller. Near the poles, the rotational surface speed approaches 0. This matters because the disaster would not be evenly distributed. At the poles, a sudden 1-second halt would be much less dramatic in terms of horizontal motion. At the equator, it would be close to catastrophic. A person standing there would not be thrown into space. That phrase is wrong. Gravity would still be far stronger than the outward effect of rotation, but the person would continue eastward while the ground beneath them stopped. The result would be more like the entire planet becoming a brake surface. A body moving at 465 meters per second is moving faster than the speed of sound in air at sea level, which is about 343 meters per second at 20 degrees Celsius. That means a person, a car, or a building fragment still moving with Earth's previous rotation could become part of a supersonic debris flow relative to the stopped ground and air layers near it. The damage would not come from some mysterious cosmic force. It would come from inertia. Inertia is the tendency of motion to continue unless acted on by a force. It is not a poetic idea. It is Newton's first law. If you are inside a car, moving smoothly at highway speed, your body shares the car's motion. If the car suddenly stops, your body keeps moving forward until a seatbelt, airbag, windshield, or dashboard applies a force. Earth stopping for 1 second is the same principle, expanded to planetary scale. The seatbelt is missing. The dashboard is the world. But this is only the first layer. The surface explanation is correct. It is also incomplete, because Earth is not a rigid metal sphere with nothing attached to it. The air has momentum, the oceans have momentum, the crust has momentum, the mantle beneath the crust has momentum. Sudden stopping would create enormous shear between layers that were never meant to experience that kind of instant mismatch. The atmosphere is the easiest layer to misunderstand. Air rotates with Earth because friction, pressure gradients, and long-term coupling drag it along. The atmosphere is not left behind while Earth spins under it. It is part of the rotating system. But if the solid Earth suddenly stopped for 1 second, the atmosphere would continue moving eastward at nearly its previous speed, especially above the surface where friction cannot instantly remove its momentum. This would create winds of extreme violence relative to the ground. Near the equator, those winds could approach hundreds of meters per second. For comparison, the strongest tornado winds are estimated in roughly that broad range. But here, the motion would not be a narrow funnel crossing a town. It would be a global atmospheric surge driven by the mismatch between a stopped surface and moving air. The wind would not merely blow. It would sandblast continents with debris, water, soil, trees, glass, metal, and pieces of the built world. Then the oceans arrive. Water has mass, a lot of it. The oceans cover more than 70% of Earth's surface, and they are already moving with the planet's rotation. If the seafloor suddenly stopped, the water above it would continue eastward. Coastlines facing the direction of that motion would be exposed to immense surges. The exact pattern would depend on basin shape, depth, latitude, seafloor friction, and how perfectly the stop occurred. But the broad mechanism is unavoidable. The ocean would not stay neatly in place. A normal tsunami is often caused by vertical displacement of the seafloor, pushing a wave through the ocean. This would be different. This would be a global horizontal momentum problem. The water itself would try to keep moving while the container underneath it suddenly changed state. Continental shelves, islands, bays, and coastlines would become obstacles inside a moving ocean. In some places, water would withdraw violently. In others, it would pile into land with destructive force. The 1 second detail does not save the situation. A second is short for human attention, but not short for physics when the velocities are high. At 465 meters per second, an object moves 465 meters in 1 second if nothing stops it. That is almost half a kilometer. If the ground stops beneath you, even 1 second is enough for enormous displacement, collision, compression, and structural failure. The next layer is acceleration. Stopping from 465 meters per second to 0 in 1 second requires an acceleration of 465 meters per second squared. Divide that by standard gravity, about 9.8 meters per second squared, and you get roughly 47 grams. That is not a small jolt. That is a lethal scale deceleration for the human body in most orientations and circumstances. Structures would not fare much better. Bridges, towers, foundations, pipes, roads, and power lines are designed for loads, winds, earthquakes, and vibrations within expected ranges. They are not designed for the ground itself to undergo a planetary scale rotational stop. But even that number is a simplified estimate. It assumes a clean 1-second stop. If the halt were faster, the acceleration would be even larger. If the halt were somehow perfectly synchronized through the planet, the forces needed would be beyond ordinary imagination. If it were not synchronized, the crust itself would experience differential motion, meaning different regions would try to keep moving at different rates. That is where the idea stops being a weather disaster and becomes a geophysical one. Earth's rotation carries angular momentum. Angular momentum is not just speed. It is rotation stored in a massive body. Earth has a mass of about 5.97 times 10 to the 24 kilograms. Its radius is about 6.37 million meters. A rotating planet is not something that can be stopped like a spinning toy without paying the energy cost. To stop Earth's rotation, something would have to remove or counter its angular momentum. The energy associated with that rotation is enormous. A rough estimate of Earth's rotational kinetic energy is around 2 times 10 to the 29 joules. The exact value depends on Earth's moment of inertia, because Earth is not a uniform sphere. It is denser toward the core. But the order of magnitude is the important part. This is not the energy of a storm, a bomb, or an earthquake in ordinary human terms. It is planetary. If some external mechanism removed that rotation instantly, the question would no longer be only what happens during the second. The question would be what kind of force could do it without destroying the planet outright. This is where the explanation must be careful. In real physics, Earth cannot simply stop rotating for 1 second and then restart without a cause. There must be a torque, an interaction, some exchange of angular momentum with something else. A giant impact could change rotation, but it would also damage or melt enormous parts of the planet. Gravitational interaction with another massive body could alter rotation, but not in a clean 1-second switch without catastrophic tides. A magical stop is not physics. It is a hypothetical condition. Once granted, the consequences follow from mechanics. If the planet stopped and then resumed rotation after exactly 1 second, there would be a second disaster layered on top of the first. During the halt, objects, air, and water would continue eastward. When the ground started moving again, it would not return everything to normal. It would collide with a system already displaced, turbulent, fractured, and moving relative to it. The restart would add another acceleration event. The world would not experience a pause. It would experience a break and then a kick. At this point, the phrase "Earth stops" needs sharper meaning. If only the crust stopped, the mantle and core would keep moving. That would imply unimaginable shear inside the planet. If the entire solid Earth stopped as one body, then the atmosphere and oceans would still lag or surge unless they too were stopped by the same impossible force. If absolutely everything connected to Earth stopped together, ground, air, oceans, buildings, people, then local destruction would be avoided. But the hypothetical force would have to act on every particle in the rotating Earth system with impossible precision. That is not Earth stops. That is rewriting motion itself. The most physically meaningful version is this. The solid Earth's rotation is halted, while everything not rigidly locked to it continues according to inertia. Under that version, the equator suffers the most. Mid-latitudes suffer less in surface speed, but still experience devastating winds, ocean motion, and structural stress. Near the poles, the horizontal speed problem is smaller, but the atmosphere and oceans would still be disturbed globally. No part of the planet would be comfortably isolated from the consequences. There is also the shape of Earth to consider. Earth is not a perfect sphere. Because it rotates, it bulges at the equator. The equatorial radius is about 21 kilometers larger than the polar radius. Rotation helps shape the distribution of ocean water and contributes to the effective gravity felt at different latitudes. If Earth stopped rotating permanently, the oceans would gradually redistribute toward the poles, and the equatorial bulge would no longer match the new equilibrium. But in a 1-second stop, the planet does not have time to relax into a new shape. It has time to shock, shear, surge, and break. This is one of the strange things about planetary systems. Some effects are slow because rocks deform slowly and oceans redistribute over time. Other effects are immediate because momentum does not wait for geology. The long-term Earth would be one problem. The first second would be another. The first second is dominated by inertia. The same principle explains why we normally feel nothing. You are not pressed backward every day by Earth's rotation because you, the ground, and the air share almost the same rotational motion. Motion itself is not what the body detects. The body detects changes in motion. Acceleration, force, pressure, shear. The inner ear senses changes, not constant speed. A smooth airplane at cruising altitude does not feel like 900 kilometers per hour. A sudden drop of a few meters can make the stomach rise. The body is not a speedometer. It is an acceleration detector. Earth stopping for 1 second converts invisible shared motion into violent relative motion. That is the whole reality check. The danger is not that humans are moving through space. We are always moving through space. Earth orbits the Sun at about 30 kilometers per second. The Sun moves around the center of the Milky Way at hundreds of kilometers per second. The galaxy itself moves relative to other cosmic structures. But those motions do not tear you apart because your local environment shares them. Catastrophe begins when shared motion becomes unequal motion. This also means the common cartoon picture is wrong. People would not simply fly straight upward. At the equator, the main motion would be eastward relative to the stopped ground. Gravity would still pull downward. The person's path would be a brutal combination of forward inertia, downward gravity, collision with ground features, and impact with air. Buildings would not calmly lean. Their upper floors, foundations, and contents would experience different loads depending on how the stop propagated. The atmosphere would not become a single neat wind arrow. It would become turbulence, compression, shock, and debris. A 1-second stop is short enough that Earth would not lose its atmosphere into space. Escape velocity from Earth is about 11.2 kilometers per second, far above rotational surface speed. Even at the equator, 465 meters per second is not enough to fling the atmosphere or oceans away into orbit. The disaster is not escape, it is collision. The material stays gravitationally bound, but bound material can still destroy itself while rearranging. The deeper lesson is that stillness is often just shared motion. A room feels still because everything in it agrees on the same frame of reference. The table, the floor, the walls, and your body are moving together with Earth's rotation. Break that agreement for 1 second, and the ordinary world becomes a high-speed mechanical system with no patience for human scale. If Earth stopped rotating for 1 second, the cleanest answer is not that everyone floats away, and not that nothing happens because it is only a second. The cleanest answer is that the planet's surface, atmosphere, oceans, and everything built on them would be forced into a catastrophic mismatch of momentum. Near the equator, the violence would be extreme. Globally, the oceans and air would turn the event into a planetary disaster, and the force required to create such a stop would itself be beyond any natural process that leaves Earth unchanged. You are moving faster than you feel. Right now, the only reason that fact is harmless is that the world is moving with you. Stillness was never the absence of motion. It was agreement.